Good morning, student. Today we are going to see redox stability of water. The stability of any species, ion or molecule in solution does not depend only its own properties, but also depends upon the solvent and also on other solutes including oxidation that may be present in the solution. There are species which are stable in water, they neither oxidize or reduce nor under disproportionation in water. On the other hand, there are species which are unstable in water, they can undergo any of the following reaction is water. The species may undergo oxidation, that is water acts as a oxidant in that case. The species may undergo reduction, water acting as a reductant in that case. The species may undergo disproportionation reaction, or species may undergo atmospheric oxidation. So there are four possibilities when a substance put in a water. So in a first we see water acts as a oxidant. So just see in this reaction your water molecule takes 2 electrons and liberate the hydrogen. So gain of electron is simply known as reduction reaction. In this case just see oxidation state of hydrogen is +1, while here oxidation state of hydrogen is 0. So this is the reduction reaction, but important note that in this reaction water acts as a oxidizing agent. This reaction shortly written as H plus aqueous plus electron gauge liberate hydrogen. Now just see second reaction, metal react with the water, going to be form MOH plus half H2. Now in this case your metal have 0 oxidation state. Hydrogen in water is +1 oxidation state. Now just see the oxidation state of metal in a product, it is +1. So 0 to +1 is happen due to the loss of electron. So reaction is of this reaction is of oxidation. While just see in this case what hydrogen have +1 oxidation state, in this case hydrogen have 0 oxidation state, so reaction is reduction. So in this case water acts as a oxidizing agent while your metal acts as a reducing agent, where M stands for alkaline earth metal like scandium, titanium, vanadium, chromium, manganese, etc. Now we are going to see the case in which water acts as a reductant, that is reducing agent. Just see in this reaction water give 4H plus ion, oxygen is liberated plus 4 electron. Now in this case oxidation state of oxygen is -2, while in this case oxidation state of oxygen is 0. So it is happened due to the loss of 2 electron, and loss of electron is simply known as oxidation, and in this case water is known as reducing agent. Standard oxidation potential for this reaction is -1.23 volt. So this is the oxidation reaction, that's why standard oxidation potential is -1.23 volt. Now if we want to write standard reduction potential of this reaction. So just write inverse reaction. So 4H plus O2 plus 4 electron give you 2 water molecule. So it is inverse of your oxidation reaction reduction. And while writing standard reduction potential, just change the sign of oxidation potential. Value is same. So standard reduction potential of this reaction is 1.23. Now for this reaction, E is equal to E0 minus 0.059 at pH 0. So at pH 0, this value is E is equal to 1.23 volt. Now just see in this reaction, 2F2 plus twice H2 give you 4 fluoride ion, 4H plus ion and oxygen. Now in this case, fluorine is present in 0 oxidation state, while in this case fluorine present in -1 oxidation state. It is happen by gain of 1 electron. That's why it is known as reduction reaction, and this species is then oxidizing agent. Now in this case, your oxidation state of oxygen in water is -2, and in this case oxidation state of oxygen is 0. So this is happened due to the loss of 2 electron. That's why loss of electron is known as oxidation, and water acts as a reducing agent. Now we are going to see redox stability field of water. Just see in this diagram, there are two lines A, B. First line is upper line AB, second line is below line CD, and this shaded region, it is redox stability field of your water. This field is near in between 4 to 9 pH. So redox stability of water is the region of pH and redox potential in which water is stable towards both oxidation and reduction, and it is from pH 4 to 9. Now we are going to discuss first for line AB, then for line CD. What is the meaning of these two lines? So the upper potential limits are the upper sloping line AB. What it tells us, any oxidizing agent whose redox potential lie above the line AB, that is whose E value is more than 1.23 volt minus 0.059 pH, can oxidize water to oxygen. Now what the lower line CD tell us, any reducing agent whose redox potential lie below the lower line CD, that is whose E value is more negative than minus 0.0591 pH, can be reduced H plus ion into water. Disproportionation in water, it is the redox reaction in which the oxidation number of element increases as well as decreases simultaneously. For example, if small amount of colorless cuprous sulfate is added to water, copper ion undergo disproportionation as follow. Now this 2 copper plus, which is colorless, when it going to be formed, it undergoes disproportionation reaction. It give copper 2 plus, which is blue in color, and copper solid, which is brown in color. Copper plus ion undergo oxidation. So in this case, by losing 1 electron, it undergo oxidation to give copper 2 plus ion, as well as Cu plus ion undergo reduction. By gaining 1 electron, it undergo reduction also to give copper metal brown. As the E0 of this reaction is positive, this reaction is thermodynamically spontaneous. Now, atmospheric oxidation. When a solution is exposed to atmosphere, then there is possibility that solute may react with the oxygen dissolved in solvent as well as in the atmosphere. For example, if a Fe2 ion is prepared in a water, then Fe2 ions remain stable in water because E0 of Fe to that of Fe2 plus lies within the stability field of your water. But if the solution is exposed to air, then Fe2 plus ion get oxidized to Fe3 plus ion by atmospheric oxidation as per following reaction. Just see how your Fe2 plus converted into Fe3 plus by reacting atmospheric oxygen. The standard redox potential for this reaction is plus 0.46 volt at pH 0. Hence, this reaction is spontaneous in nature. In our next class, we are going to see reduction potential diagram, that is basically Latimer's diagram and some numericals on it. Thank you very much.